Motorcycles of today are the true marvels of engineering. A basic model of inner parts of a typical motorcycle is shown here. In this video, we will explain the basic function of each of these parts in a motorcycle. Let's begin from how a motorcycle engine starts. All motorcycles have either a kickstarter or a self-starter or both. A kickstarter mechanism is simple yet interesting. As the kickstarter lever is descended, a helical spline forces the gear to slide and engage with a freewheeling gear on the main shaft. As the lever is descended further, the gear spins on its axis and transfers the power to the clutch hub. The clutch hub transfers the power to the crankshaft and eventually to the engine. In a self-starter system, a battery-powered motor provides initial spin to the engine. Once the engine is started, the starter motor has to be disengaged from the crankshaft to prevent damage due to excessive speed. This is achieved by using a one-way clutch. The model shown here is of a roller-type one-way clutch. It has an outer race and an inner race with small rollers. As the starter motor spins the outer race in one direction, the rollers get trapped between the surfaces and the power is transferred to the inner race and thus to the crankshaft. Once the inner race starts spinning faster than the outer race, the rollers get released, causing the inner race to spin freely. Like every four-stroke gasoline engine, motorcycle engines require a source of ignition to ignite the air-fuel mixture for power strokes. A spark plug is used for this purpose. The spark plug requires voltage in excess of 20,000 volts to fire properly. In this particular model, the voltage is obtained from the stator of the motorcycle, although a 12-volt battery may be used for the same purpose. The stator is a stationary coil of wires. The flywheel of the motorcycle has a set of permanent magnets which revolves around the stator and produces alternating current in the coils. Each output from the stator has different purposes, as shown here. Continuous operation of the engine. The intake and exhaust valves are controlled by using a timing chain, as shown here. As long as the engine is running, the crankshaft rotates and transfers power to the other components for proper operation. Single-cylinder engines generally use a counterbalance to reduce the vibration caused by unbalanced forces. The clutch helps in smooth transfer of power from the crankshaft to the transmission system. The transmission system helps in altering the speed and torque as per our requirement.